Hi everyone, welcome back to Java 1 for All. In this video I will give you some guidelines to decide when you should use parallel strings or when you should stick with just regular strings. So the rule of thumb is always benchmark. I mean, there is no better way to decide if what you are doing is going to have a huge impact in the performance of your system if you do not measure. So just grab the data as close as possible to the real data that we will be working with and do some benchmark. You can do simple stuff using the current time millis like we did, or you can go for more fancy stuff using external libraries. But the idea is you should try and see if parallel strings is something that's going to improve or decrease the performance of your code. And as you saw, it's pretty easy to just make the strings parallel, so you can do this test pretty easily. Second thing, unboxing and boxing. So as you know, when you are working with primitive types and wrappers, there is this boxing and unboxing, and you should be careful. If you are all the time boxing and unboxing, you have the problem that you are still giving some of your processing time to have the task done in parallel threads, and you still have to do unboxing and boxing. So be careful if you are doing boxing and unboxing. Maybe you should try to see if the performance is better with just one thread. Second, some methods, they are not good to be used with parallel strings. For example, limit and find first, they are not good candidates to be used in parallel strings, and especially because the find first, you have to have everything sorted first. The find any is another story. The find any is a good candidate to use with parallel strings because, well, it doesn't matter the order. So if you don't care about the order, then parallel strings is a good choice. But if the order is important, parallel strings may hit your performance. Then you have the, let's call, computing time. So usually when you are working with strings, you have the elements, you have a number of elements, and then you have the processing time for these elements. Usually the rule of thumb alongside with benchmark, if you have a really high processing necessity, let's say that you are going to benefit from parallel strings because you have multiple threads kind of thinking in parallel, like multiple workers thinking about the same problem but different parts of the problem, and later on they will merge everything together. So usually when you have the processing here higher, it will probably have benefits in using parallel strings. Then you have the amount of data. As I said, every time you are using parallel strings, you are using some processing power to split that task. So for example, you do have some time, memory, and processing power needed to split the data into smaller parts where multiple threads can work together. If the amount of data is not that big, the time and processing power you're going to consume to split is bigger than the task itself of processing that data. So a good idea is to make sure that you have enough data to make it worth it to have it running in parallel. Then you have the type of collections. Some collections, they are very good. For example, array list is excellent to work in parallel strings. Linked list is very poor choice because you have to go through the entire list every time. For example, using the streams dot iterate is not good. The range closed from the long string in string is good. The set is also kind of good choice as well. So be careful with the type of collection. Do some research and see if that collection it's good to work with parallel streams. And then you have to be careful with not only the amount of data, but there is also the size of the string. So usually if you have a predefined size, you are going to have better performance. As you saw with iterate, if the string doesn't know how much data it needs to work with, it's probably take more time to solve the problem. And then you have this. That's the merge processing. So behind the scenes, the string is using a framework called fork join that basically will split the task, and then it will join the results. So in a very simple way, it would be something like this. If task is too small and can't be divided, do it sequentially. Else, split the task, then call it again recursively, and then wait until all tasks are done. So this call it again is basically to figure out if it's still too small or no, and then join the result. So basically this is what you have to be careful. So how does it work? Imagine that you have a task, and this task is big, so you can split this task. This task it's going to go all the way to our else, and let's say here. So we are splitting this task, and this will give birth to another two tasks. But it's going to call recursively, and it will figure out, hey, I still can split this in another two tasks. So now we are going to have other two tasks. Then we have here, oops, and here. So what happens now? Now it's small enough, actually it's not big enough, and we are going to do it sequentially inside the threads. But after you do this processing, you will have something that's called join, because this will give us a result. So if you are summing, this is a huge list of numbers, it's going to split the numbers, and then after we have small enough pieces, it's going to start summing, and we will get results. So wait, I don't want you here. So we are going to get results. So for example, we have the results from this one, the first one, and we have the results of this one. So at this point in time, it's just the results. So if we copy, we have the results for all of them. So it's still waiting for all the results. And after you get the results, it comes the join part. So basically the join part is getting the results together to have a final result. So this one will have like a result together. So this joining will have this result, and this other joining will have this result. And in the end, you are going to have a final result that is from these two. So as you can see, this will have some impact. There is some performance hit to do this join together. And if this is way too big, if it's taking a very long time to do this join together, maybe it's not a good idea to use parallel strings. So this is something that you have to be careful. You are forking, and then you have to join together. And sometimes joining or merging the results can cost you a very huge effort. So basically that's it. Well, it's not very deep, just let's say overview. If someone talks to you about the fork join and they are looking for kind of some practices to getting started, this is the way to go. But I advise you to every time just do your own benchmark. So I hope you enjoyed. That's it for strings finally. So I think you can move on to the next topic. See you there. Bye.